This is a video for AQA Mechanics, Work, Energy and Power Section 3.1, Resolving Forces in Work and Power Problems. So the diagram shows a crate which is being hauled up a slope which got a frictional force acting on it by a winch. So the winch is producing a traction force up the slope, Ft, and the frictional force acting down the slope against the motion, and obviously we've also got the weight and normal reaction shown in on the diagram. First part of the question says that if the object is moving at a constant speed, then what is the total work done if it's working at 6 kilowatt power and takes 50 seconds to move. So we have that the work done is equal to power multiplied by time. So that's 6 kilowatts, so 6,000 multiplied by 50 seconds gives 300,000 joules, which of course is 300 kilojoules. So the total work done over the 50-second period, 300 kilojoules. The second part of the question asks us then to work out what is the resistive force Fr shown on the diagram. Now we can say that the work done by the winch will be equal to the work done against this frictional force and also the component of the weight which is acting down the slope. So that would be Fr, and then the component, we'd need sine 35 degrees, so we've got a 35-degree angle, so the component down the slope will be 1600 G is the force, and then sine 35 degrees. So that's the total force acting down the slope, and we can use then that the work done by Ft will be equal to the work done against these two forces. Now doing that, we're using the fact that we've got constant speed, so therefore there's no increase in the kinetic energy, and also we're considering the weight as being a force down the slope, so that we don't need to look at the idea of gravitational potential energy, although that would be an alternative to say that the work done by Ft was the work done against Fr plus the increase in the kinetic energy, and the potential energy, and you'll see that this expression here, once we multiply by the length of the slope, will be equal to the increase in the gravitational potential energy. So what we're saying then is that the work done, which remember was 300 kilojoules, so 300,000, must be equal to Fr plus 1600 G sine 35. That's the total force down the slope. Now we've got to multiply by the distance moved, which we're told is 25. So therefore multiply that by 25. And then if you calculate that expression, we end up with Fr, frictional force, is 3006 newtons. So let's just check through that again. Then we calculated the work done as being 300,000 joules, 300 kilojoules, and then we've taken the force down the slope, or the component of the weight down the slope, multiplied by the distance it's moved, 25. This expression here is equivalent to the gain in the gravitational potential energy. So if you wanted to consider it that way, you could do here this height that we go through, h, would be equal to 25 sine 35 degrees, and then if you multiply that by the weight 1600 G, so that's mg, so mg multiplied by h would be the 25 sine 35 multiplied by mg 1600 G. So that completes this video on resolving forces in work and power problems.